Derivative of trig functions. Do you guys want to see the, okay, I guess it says, let's see if we can derive the derivative of sine by looking at tangent slopes and plotting their values. So what you're looking at here, this is y equals sine x. So y equals sine x. If you didn't recognize it, it's going through the origin. So that's sine x. So I'm looking, and it says plotting tangent slopes, the values of the tangent slopes. So in case you're wondering, every time you have a max or a min, you have a horizontal tangent. You guys see that? And at every point of inflection, right on the x-axis, you have a slope of 1 or a slope of negative 1. On the x-axis, at every point of inflection. Maybe I should have made those black so you guys can see. Do you guys see those in black? All right. I'm plotting the value of that slope. Cool or not cool? Cool. Okay, so wherever I have horizontal tangents, I'm gonna plot the value of 0. So let me change my color to blue. Oh, here, no, let me go to this guy, blue. I have all the colors because I have the Pro. So here we go. So I have a horizontal tangent, so I'm gonna plot that color. I'm plotting derivatives. So wherever you see a blue, I'm plotting y prime. So that x value here, at the point of inflection, that's a slope of 1. I'm plotting a 1 at that x value. Let's see here. I'm plotting a 0. Maybe I should have put the radians, right? Pi over 2, pi, 3 pi over 2, all those. That's fine. Not a big deal. Negative 1, 0, positive 1, 0. Let's see. That one's at pi over 2. So pi over 2 plot 0. And then, that one's at, oh yeah, that one's at pi over 2. And then this one's at, let's see, what's that, pi? So pi plot 3 pi over 2, and then 2 pi. Okay. What do those blue dots look like? What type of wave does it look like? Wherever you have a max, do an upside down bowl, aim it towards your points of inflection. Wherever you have a min, do a bowl. Sorry, Dr. George, if you're looking at this and I'm not calling it the technical right name, I just think it's a bowl. Look at that. That's my derivative curve. Isn't that cool? What curve does that look like to you guys? That's cosine x. So from now on, the derivative of sine x is simply cosine x. We can do a formal proof. Let me know. We've actually done it already on one of the UH quizzes, UH quiz Trig 5. But in case you don't remember or you wanted to see it done again, I'm not going to do it right now. Well, we can, but I feel that right now we got other things to do or worry about with our time. But let me know. We can derive it. How do we feel? Nothing crazy, right? So from now on, if they tell you that y equals sine x and they tell you what's the derivative of sine x, you're going to say that the derivative of sine x is cosine x. Okay, before going to the next page, take a guess. What do you think the derivative of cosine x is? Almost. What do you think goes in the front of sine x? So, are those easy to remember? What's the derivative of sine x? What's the derivative of cosine x? Okay, so here's how we're going to do it to remember all the trig ones. If you're taking the derivative and it starts with the letter C for trig, and this applies to all of them, even the hyperbolic ones, If it starts with the letter C, it's going to be negative. Someone once said, and I don't know if it's maybe you guys want to use it. I don't know. Oh, cussing is bad, and cussing starts with C, so that's just negative. So everything that starts with C is negative. I don't know. They're trying to make the connection C, cussing, cosine, cosecant. Okay, Landry's just looking at me like, what are you talking about? Okay, so if it starts with the letter C and I'm taking the derivative as negative, there it is. That's all you got to know. All right, so there we go. Really easy to remember. What's the derivative of sine? What's the derivative of cosine? You guys, repeat it with me. What's the derivative of sine? What's the derivative of cosine? One more time. Let the YouTube people hear you. What's the derivative of sine? What's the derivative of cosine? Thank you. That was a lot better. See? Come on, guys. All right, here we go. Look, I'm taking the derivative of x squared sine x. What rule do I need? What rule do I need? We just covered it. What rule do I need to take the derivative? No, guys. This is a product. It's something times something. Product rule, guys. Product rule. So write in there that you need the product rule for derivatives. So here's the product rule for derivatives in case you don't remember. So UV, so I'm going to write y prime equals first times derivative of the second plus second derivative of the first. I prefer you do it that way. I know that delta does it in reverse order because it doesn't matter. There's a plus symbol. So they do that because when you do quotient, all you got to do is change the plus to a minus. But I really recommend, that's fine if you like it, but I think it's easier this way. Later on down the line, we're going to go in reverse. And I guess, it doesn't really matter too much, but I think I still prefer this way. Okay, are we still okay? All right, here we go. Y prime first, and I just write x squared times derivative of the second. The sine x is my second. What's the derivative of sine x? Cosine x plus the second sine x times derivative of the first. What's the derivative of x squared? Done. That's what you're doing in today's delta. But some people were super confused today when I'm just call this A2 because this was A1, right? The original. I'm just making up a problem. I'm going to go x cubed minus, and you know what? I'm going to do the same thing. X squared sine x. Some people were super confused when we were working on this. And I'm like, guys, find the derivative of that. And then look, all you got to do, y prime equals, this is not a product rule. That's just x cubed. 3x squared. Minus, that minus is this minus. And then maybe put a bracket to help you out. And then once you're a pro, you can just put that minus with the negative. And put that minus with the x squared. First, derivative of the second. Plus second, derivative of the first. See? And then just distribute the negative. So 3x squared minus x squared cosine x minus 2x sine x. That's y prime. Notice that's a second. So there it is. Hopefully we don't get any confusion now that we've done that. What's up, Salali? Are you sure? Let me know. You guys ready for the next one? Don't worry, we're gonna go slow. I know you guys are tired. It's the last class of the day, and then you got your ring ceremony, and some of you haven't slept since 1 a.m, and some of you have random sleep schedules where you sleep throughout from 7 to midnight, and then wake up and work for 2 hours, and then go back to sleep. I know because those are the same habits I have. All right, here we go. What rule do I need for this one? Quotient bottom times derivative of the top. What's the derivative of cosine x? Negative sine. Negative sine x. Plus or minus? Minus. Now what? Cosine x top times derivative of the bottom. What's the derivative of sine x? Cosine, but I have a negative in the front, so I got to put negative cosine x all over bottom squared. Maybe I should have put the rule on the side before I started it, huh? Okay, here's the quotient rule. I'm going to put it here on the side. Where did I put it? Right here. Y equals u over v. So y prime equals bottom, v times derivative of the top, u squared, u prime minus top, u times derivative of the bottom, v prime, all over bottom squared. Does that help, like referencing? Okay, there it is. There's the quotient rule. Low d high minus high d low over low low. No, that's how it is. I didn't make that up. You like it? Low D high minus high D low over low low. Low, 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 low. Okay, I'll stop. That's a song. You know, right? Okay. All right. Let's go ahead and figure this out. You're done with calculus. Guys, oh my God, I just did a sin and you guys didn't even tell me. Isn't this a derivative? But look what I wrote. I wrote u. This would have been definitely taking points off. That needs to say u prime. That's a derivative, guys. It needs to say u prime. That's a derivative. You should have told me. It was your job. Nah, I'm kidding. Here we go. U prime equals negative sine x plus sine squared x. Negative times the negative is a positive, plus cosine squared x all over 1 minus sine x. We'll close it squared. Notice that in the numerator, I have sine squared plus cosine squared. That equals what? 1. Negative sine x plus 1 over 1 minus sine x, close it squared. You could just cancel it right off the bat right there. I'm going to rewrite it so the factors look the same. Well, they are the same, but so they're in the same order, I guess. And now what can I cancel? Yeah, 1 minus sine x. Cancel, cancel. So your final answer, u prime, is equal to 1 over 1 minus sine x. And there it is. How do we feel? Yeah, you should. You should feel good. What do you think, Maddie? The derivative of 1 minus sine x is negative cosine x. Because the derivative of sine is just cosine x. And the derivative of 1 is a constant. The derivative of the bottom, right? So bottom times derivative of the top minus top times derivative of the bottom. So you're confused on this one right here. Well, that comes from, let me just write it. So look, I'll write it here on the side. I'll write it right here. If I were to tell you that y equals 1 minus sine x, I don't have to use product rule or anything. It's just 1 minus something. Y prime is going to equal negative cosine x. Because the derivative of sine is cosine x, but that negative is that negative. So, well, 1's a constant. So the derivative of 1 is 0. Cool? Cool. All right, now that we know the derivative of sine, we're going to do the derivative of tan. I don't know why I even said it like that. I didn't mean to. All right. Y'all ready? It's not even that bad, guys. It's not even that bad. I'm having a good time. You guys aren't having a good time? I'm having a real good time. All right. We could easily tell you just to memorize what the derivative of tan is, but I don't want to be that way. I don't want you to be that way. So let's break this up. d dx, that just means take a derivative. And I'm going to break tan into what over what. You guys all took pre-calc. Perfect. Sine x over cosine x. So now, if I want to take the derivative of sine x over cosine x, what rule do I need? Quotient. So let me write the quotient rule up here so you guys can see it. Y equals u over v. So that equals bottom times derivative of the top minus top times derivative of the bottom. And note, okay, that's a linkage error. I can't believe I did that. Y prime equals bottom times derivative of the top minus top times derivative of the bottom over bottom squared. I knew something was off. Man, today's an off day. Are we still okay? We didn't do too much damage, did we? All right, here we go. You guys ready? I hope I didn't do that before. Now let me go check my work from before. Okay, good. I did y prime there. All right, here we go. Bottom cosine x. I will put everything in parentheses. Times the derivative of the top. The derivative of sine x is cosine x minus the top sine x times the derivative of the bottom. What's the derivative of cosine x? Negative sine x. Put it in parentheses so it doesn't look like you're subtracting. All over bottom squared. You can write cosine x squared like this. But remember, that just means cosine squared x. So that's actually how you should say it, cosine squared x. Because if you say cosine x squared, it's the x that's being squared. Unless you slow down and say parenthesis cosine x close parenthesis squared. And you guys know that because you guys had pre-cal last year. And you guys, I heard, had a really good pre-cal teacher. Okay, sorry guys. All right, here we go. Cosine x times cosine x. Cosine squared x. Not everyone at the same time. Minus a negative, so that's going to turn into a positive. So I'm going to write plus sine squared x all over cosine squared x. Are we still okay? And then I see the cosine squared plus sine squared, and that's the same thing as 1. So I have 1 over cosine squared x. And you could leave it like that. But what's 1 over cosine? Secant. So, but this one's squared, so I'm going to say what? Secant squared x. So from now on, the derivative of tan x is simply known as secant squared x. Say it with me. Derivative of tan x is secant squared x. All right, one more time so the fans can hear you. Derivative of tan x is secant squared x. Okay. Now, the one thing that sometimes you guys are going to tell me later on, you guys are going to be doing this. That is wrong. You got to tell me that you're taking the derivative of tan x. If you tell me tan x equals secant squared x, you're just telling me to solve for x. Where does this left equal the right? So you need to put d dx like that. Cool? Okay, that's just a side note. All right, look, use your intuition. I haven't even asked a question. Let me ask a question. Don't look at the next page. Use your intuition. What do you think this derivative is? Use your intuition. So the derivative of tan is secant squared. What do you think the derivative of cotangent of x is? I heard someone say it. No, not negative secant. You're close. Well, kind of. You got the negative part right. Negative cosecant squared. We could have derived it if you wanted to. But see, like, you have good intuition, guys. We didn't even derive it or anything. You just said it. So if you go to the next page, actually, don't go to the next page yet. Let's solve for this. This is what you need for this one. And here we go. It says it wants g prime of pi over 4. So before you got that, you got to find g prime of x first. So what's the derivative of x? 1. All right, tell me if you guys like this or not like this. The derivative of 2 cosine x is going to be a negative 2 sine x. Do you guys like that or no? Or are you feeling inside of you like you should have used product? We'll talk right now. And what did you guys tell me the derivative of cotangent x is? Okay, let's talk about the 2 cosine x. If we would have used product rule, in case you're thinking that, like, Chav, why didn't we use product rule? We could have. You could have said that's first and that's second. I just want you to notice that first does not have a variable. So you don't need to use product rule because that's kind of like when we did notes 2 or notes 3. Well, I already forgot what notes it was. Note 7, the coefficient times, like, let's say the derivative of x squared was 2x and we just multiplied the coefficient by the exponent. It's similar to that. So look, if you did the product rule for this, first times the root of the second, negative sine x, plus second, cosine x, times the root of the first, 0. Look at that. That goes away. Negative 2 sine x anyway, see? So you don't need to do product rule if you have a constant in front of the cosine. You just change it to whatever it is, negative or positive or whatever the derivative of that trig is. Does that make sense? Hey, don't fall asleep. That's the demerit. Yeah, if you think I'm talking to you, I'm talking to you. No, sorry guys. I don't know what's going on with me right now. I'm usually not like this. All right. I guess you start acting silly right before you. Okay, I better not. Yeah. Okay, here we go. All right. How do we feel? Do we feel okay? All right. No questions so far, right? We're good. Let's now do g prime of pi over 4. G prime of pi over 4 equals 1 minus 2 sine of pi over 4 minus cosecant of pi over 4, and we're squaring that. So let's see, 1 minus 2, and what's sine of pi over 4? Square root of 2 over 2. Minus, and then cosecant's a reciprocal of sine, but they're being nice. We're in quadrant 1, and it's pi over 4. So 2 over square root of 2, and then square it. Let's say we finally get 1 minus, these 2's cancel out. You get square root of 2. Minus, let's see, 2 squared is 4. Square root of 2 squared is 2. So that becomes 4 over 2. So that's 1 minus square root of 2 minus 2. And I guess you don't have to do all those steps. You could have just did it immediately, right? Negative 1 minus square root of 2. How do we feel, guys? Are we okay? Okay. Nothing crazy, right? Cosecant's a reciprocal of sine. So all I did was took the reciprocal of that guy and just squared it. Oh, that's fine. Well, it's not fine, but yeah, you know what I mean. Like, yeah, it's cosecant, so just the reciprocal sign. All right, here we go. On the next page, those are the derivatives. Tonight, before you go to sleep, I recommend that you look at it for at least a minute or two. You got to know those codes. You can derive them from scratch. Earlier this morning, sixth period, I think sixth period wanted me to derive the cosecant x, so we derived it. Do you guys want me to derive any of these from scratch? Or are you guys just good just looking at it? If we can, let me know. We can derive it real quick. It doesn't take long. Do you want me to derive one? Which one? Doesn't matter which one. The same one? The cosecant x? Okay. So here we go, guys. And I know it says find the equation of the tangent for this. So let's go ahead and scratch it out. We'll do that another time. It's not a big deal because that's just using the calculator. We can do that tomorrow or something. All right, here we go. I'm finding the derivative by hand of cosecant x. Well, you know, so I'm going to write d dx, but I'm not taking the derivative yet. You know that cosecant x is just a reciprocal of sine x. So there it is. So I'm going to use quotient rule. Bottom. So now it is. Look, there it is. I'm not going to write d dx. I'm just doing the derivative. Bottom, sine x. Times root of the top, 0. Minus top, 1. Times root of the bottom, cosine x. All over bottom squared. This is going to go away. Sine x times 0. Bam. Out. So I have, right now at the moment, I have a negative cosine x over sine squared x. I want it to look like that answer that I got there, negative cosine x, cotangent x. I want it to look like that. So let me see. I'm going to go ahead and go negative 1 over sine x times cosine x over sine x. OMG, this is negative cosecant x. This is cotangent x. And see, you can derive them all from scratch. But isn't it better or faster if you just memorize them? Yeah. So just... Well, no, I'm not telling you to be a robot because, look, we just derived it. Okay, then derive them from scratch forever and ever. So look how easy it is to remember, guys. They're related. Look, use your intuition. If the derivative of tan x is secant squared, and you guys told me the derivative of cotangent x is negative cosecant squared, you look at your intuition. So just memorize these two right here. What's the derivative of secant x? Itself times tan x. So the derivative of secant x is secant x tan x. Cool or not cool? It kind of rhymes too. What's the derivative of secant x? Secant x tan x. Look at this. That's a cosecant x. So it's self. And then look, instead of a tan, a cotangent. See? So they'll call related there. What's the derivative of cosecant x? Negative cosecant x cotangent x. What's the derivative of secant x? Secant x tan x. What's the derivative of tan? Secant squared. What's the derivative of cotangent? Negative cosecant squared. See, look how they're all related. What's the derivative of secant x? Secant x tan x. What's the derivative of cosecant x? Negative cosecant x cotangent x. So it's kind of fun. Just do a little game where you just memorize it. I'm not telling you to be a robot. We just write it from scratch. You know where it's coming from. But it's faster if you just make sure you just know it off the top of your head. Cool or not cool? Okay. All right, guys, we're almost done. We got one left. And then we'll set you guys free. I know you guys are dying to start your delta or to get up and drink some water or something. All right, here we go. Y equals secant x. I want the second derivative. So first, I got to find my first derivative. That's what this means, right? That means second derivative. All right, let's see. All right, so Lali, ready? What's the derivative of secant x? No, don't look. Yeah. Secant x times tan x. Good job. All right. All right, Kunduru. Hold on. Don't freak out. I'm about to do a second derivative. To do a second derivative, let the record show that she is super calm. That's what you said. To do the second derivative, what rule do I need? Product rule. What is the product rule? So tell me, guide me. Second derivative, y prime prime equals first one, so secant x. What's the derivative of tan? I don't know it. Yeah, it is. Secant squared x. Good job. That's it. Plus the second one, tan x. Of the derivative of the first one. Okay. I don't know what the derivative of secant x is. Do you? Oh, wow. Secant x tan x. Wow, man. That's awesome. That's it. You're done. If you want to make it pretty, if they tell you to simplify it, I have a secant there and I have a secant squared there. So that's going to be secant cubed x. I have a tan here. I have another tan there. And this is a product plus secant x tan squared x. Does that make sense? Okay. So right now, before we start any circuits, all you need is more experience. All you're doing is following rules. So it should be one of the easier things to do. You're just following rules. On Delta Math, when you go to Delta Math and it says any form, that means you do not have to simplify. Do we know that? And if it says simplest form, that means you got to simplify. Do we understand the mechanics of that, guys? All right, that's it, guys. Let's get to it and make sure that you ask me questions if you have any questions.